all kind of different technologies. Okay. All kind of different technologies. So I thought at some point it's good if we'll meet, discuss common issues, um, the API that we want to see in KubeVirt. Like one of the things that I was worried about some kind of an explosion of technologies in the API that each one of these will go to different directions. We won't have a common API for attestations, and won't have a common API for things that don't require attestations, but for people that they want just some kind of um, additional security. So the question is, does this make sense, and does it make sense to unify this API? That's from my point of view. The other topic is how we're going forward with testing that we should discuss, and what are the common issues that we are facing with bringing these technologies. Some of these technologies, they need additional containers to be in the Virt launcher pod. Some of these need communication with the host. So ideally, we should discuss those, and whatever everybody feels they need to discuss. So we could begin, I guess, with defining what this work group should look like and what is it about. Um, yeah, so I'll be quiet now.
Yes. So I think regarding a common API, I guess it can make sense, or like an easy API. I guess we have to abstract the scaling constraints then, though, like come up with an abstract notion of this supports some kind of enhanced security technology, and we then configure it in the details based on this common denominator. Because otherwise we would have to go through CPU flags, and maybe if something like QGS or other daemons are available on the host, right?
Yeah, one of the challenges, I think it's exactly that. I mean, we are talking about adopting confidential virtualization in KubeVirt, but even at the low level platform, it's still pretty much, I mean, open evolution, right? The design is still evolving. My concern is sometimes we define, I mean, an abstraction now that it's going to be invalid in a couple of months' time. Uh, right now, for example, I don't think anyone can do live migration, right? And then, I mean, imagine us, I mean, defining a machine type or defining an abstraction to schedule, I mean, workloads that are able to run in confidential, I mean, mode, but not with live migration. And then we need to introduce a new one in a couple of months where we, I mean, are able to do live migration. And then a new one where we are able to hot plug things. And then a new one in which, I mean, we are able to do, I don't know, runtime integrity measurements, runtime attestation, right? I mean, my concern is, I mean, there's so much there's still happening in the underneath with what, how do we start? How do we actually stage this so that we can take advantage of, I mean, productizing this as soon as possible and getting feedback, getting, let's say, getting users onboarded as soon as possible, but not disrupt their experience once more things come in the future, right, from the platform.
Makes sense as well.
Yeah, I think what I could say is that um, some of these scheduling decisions, whether we support live migration or not, I mean, we could just, I mean, this is happening in a different level than the API itself. I mean, we could identify that certain technology is being used and then block live migration entirely. So that's something that's a condition that is being raised based on something. But in terms of API, we could, right now what we have is a mechanism to introduce new features as alpha, and we could just go with this approach and take it slowly. So we could separate. So right now what we have is some kind of a launch secure struct, and then we can release these technologies in there, or we could come up with a unified API under this launch secure struct that would just have everything that everybody needs with optional fields in them. And that will be just one struct that everybody is working in, instead of having like many of them. And then like the more of these technologies we have, the more conditions we'll have to, more validations we'll need to do. If we have just one API, the number of validations, I think, drops significantly. So that was my point.
Yeah, so I'm not so sure. Like right now, it seems like the technologies are supporting quite a different set of devices and configurations. So we have some TDX POC as well, and we had to really try out a lot of configurations to block certain things so that the host or the guests don't crash. Some devices are supported, some may be supported sooner, and so a lot, like TDX alone has a huge set of validations we had to add, and I'm not sure how. I could assume that on SEV we are also not complete yet on the validations, and they're probably different as well. So I'm not sure if it gets easy with the validations. Like we would have to find we would have to define then a set of basically, at least for SEV and TDX, we would have to define a validation set which is a sum of both no-goes, right? So I'm not sure if this is good or nice.
Can we try to define a, and there are a couple of hands raised, so I'll stay quiet. I don't know how is the etiquette here. I mean, who calls the next hand?
I think there was only, yeah, sorry.
Yeah, sorry, I didn't know. I just put the hand up. But yeah, I think for me personally, this could be a bit of a chicken and egg thing where, as someone said earlier, because all the underlying kind of technologies are still in flux, we might just need to keep things quite verbose for the time being and potentially abstract things later and simplify things. From what Roman just said as well, there might be, it sounds like there's the different technologies are exposing different configurables and aren't necessarily something that you can kind of dry out into a common set or anything. So this might be something that we do later on in the process when folks have got a better handle on how everything's expressed as well. Like personally, I still haven't seen like a KubeVirt domain expressing all of this stuff for TDX, for example. But in the PR that I think Roman just mentioned upstream, it's exposing a policy, for example. So I don't know if we just need a policy exposed or if we need other things. And over time, hopefully, folks in this group will get a better appreciation of what TDX requires, what other technologies require, and from there we can kind of think about how to kind of generalize and clean up the API potentially. But for now, I think just try it. But yeah, we probably just need to be a little bit more verbose than we'd ideally be.
Could be. I mean, the problem is that sometimes you come up with some kind of an API, but that's not just the API. It's also tons of different validations across the code. Right now, if you just grab for SEV in KubeVirt, you will see that it's like all over the place. And here we check for SEV, there we check for SEV. So, I mean, that's my concern, that we will have tons of these around the code that we will not be able to consolidate later. That's my worry.
I think that's a concern. I would just say we already have the launcher security field, right? So we can probably do a better job of in the code bases in the appropriate places, like in the controller, in the API, in handler and launcher, having clearer entry points for the launcher substruct, like where all the validations for the different things are. That would where possible, like, I mean, yeah, or like always, or at least come up with a common pattern on how we tie them in. I think also some converter refactoring may probably be necessary to better combine those. But I think with the launcher security structure, we could have this entry point for internal concerns already. For a common API right now for users, yeah, like Lee said, I'm just not sure if we have the right time for that.
Sounds
Should
good.
we create a table or spreadsheet? I mean, trying to compare the different targets that we have or we might want to have in the future, and what are their inherent properties. I mean, some of them will support policy, some of them will not. Some of them will require, like, TDX, code generating service, that is processing the host. Some of them will not. So we and some of them will require special firmware. Maybe some of them will not. I am not sure how we want to fit those in, and try to find a minimal common denominator, right? That is, where we can start in a definition of this, right? Is S390 a target here, right? I mean, they have a secure executions thing, right? CCA, I guess, is certainly a target. SEV and TDX are targets, right? I mean, is there anything else? I mean, do we need to map those things out?
Yes, you're right. An S390 is definitely something we would consider, but I think the problem is it's an unknown unknown. We don't know what we're going to hit in the future, so it's almost agony to try and accommodate it.
It's being recorded.
So for S390, at least from what I've seen in the proposal that they are going to implement for this cycle, is very simple. I mean, they don't really have anything. They just need to land on a node that supports S390, and this is pretty much it. For other technologies, there needs to be a device, or there needs to be something else. So yeah, I mean, we definitely can start with the spreadsheet and put those in. Does it make sense?
Yeah, I'll be happy to help. Start something and CC me. I have a couple of things that I guess are right off the top of my head that I would like to map, and then we can iterate and see. If any of those things make sense to track that way, or if we don't need to track. Anyway, try to keep it simple, right?
All right. So next topic, testing. So I'll let Roman start.
Yeah, so we had a discussion with, like, I guess Red Hat has a lot of discussions with Intel as well about this topic. What's going on with the code all over the place. We had one as well. And the Intel guys they had their device path through Penge, which was kind of right until recently their main entry point for if you want confidential domain push GPUs, which kind of made it the main entry point to get the patches at the moment. It had at the station until recently, then it disappeared. And the background was like they started a cooperation with Ubuntu for LTS long-term support there. They just did a release. I thought it may be interesting as a testing target because it provides out of the box a host kernel which works and out of the box a guest kernel which works. So that may be helpful for testing. For QEMU, I don't think we have a canonical place for QEMU in that regard. At least Intel is planning to have supported QEMU patches which they are supporting on the Ubuntu side as well. So it may be a place to get them from. Like before that, we had to collect them all over the place, sometimes even in 3 different repos or so from Intel repos to somehow get something working. Yeah, it's just. So,
but this is collapsing, and this is getting merged in the next few months. We've been waiting for 3 years, but I guess we are finally here.
Yeah.
My understanding is that we should be having this all upstream in the next 2 months, right?
Hopefully. I mean, they have the patches really ready looking for a long time always, right? And then it starts again and again. But I hope so as well, yeah. Would make everyone's life so much simpler.
Yeah, but that's just one part of it. I mean, then the other part is hardware and CI and all of this stuff. Are we shooting for this, or um, each technology will validate it separately? I'm not entirely sure how do we want to approach this.
Maybe that is Intel someone to approach there if they want to donate the CI machine or something, for instance. I think AMD SMP is probably relatively easy to get a server for, right? But TDX machines are still relatively rare.
We should have already provided one to Brian. I think we already gave one to him.
That's I didn't know about it, but yeah, I'll.
For TDX or for SMP?
For SEV SMP.
Mhm.
Yeah,
I remember a mail thread about it. I remember there was a problem with it, but yeah, I'm not sure.
Yeah, there was a problem with the firewall. We went ahead and resolved that now.
Oh, awesome.
How does it work for you? Are you providing like internal systems for the community to use?
Yeah, that's about it. We provide them an IP address and a port, and they connect to it, and they can do what they want with it. It's a Kubernetes cluster, just a single node.
I think I'll go. So yeah, I think AMD has already provided the hardware. We did ask. So Miko is here, but we have a meeting with Intel where we requested Intel to also share a hardware with the community because that generally blocks all the review. And AMD already has the initial KubeVirt pull request. Previously, it was owned by Google, but now I think someone from AMD has taken over. So once that machine is in place, I think Brian was following up on it, but then he was on PTO until yesterday or so. So we need to check back.
Yeah, so yeah, we'll have a status on this for the next call. But this is for okay. So, but this is for CVSMP, and we need to figure out Intel and whatever else we want to support.
Yeah, I can look into it. I cannot make any commitments or guarantees. We have a similar setup with confidential containers where we provide some bare metal systems for the CI to run. It's just like a bit of a scalability issue that we would have to maintain these internal systems for all of these projects. But I can look into it.
Perfect. Thank you very much.
One question though. So do we consider the CI system availability as like the blocker for this work to continue? Or is there like a parallel path that we would continue with the code reviews and design and architecture and then work to get the CI system in parallel to that?
So I would say for alpha, I don't think that we should require any CI. Just like the initial steps. I don't know if others agree. But in general, going forward, moving from alpha to something more stable, just in general in this space, I think we will have to have a CI.
Yep, I agree.
Yeah, certainly makes sense.
So Vladik, we do have the pull request for in KubeVirt community for both SNP and initial TDX implementation. So is that something that you or others who can probably, I mean, yes, we still don't have the CI in place, but it would be good if folks in the community and start looking at it and sharing some feedback.
Yeah. So I think one thing that is important to note is that in order to move forward with these pull requests, we need we need a web. So we need a proposal, and then that proposal will be scheduled for a release, like reviewed and scheduled for a release, and then we could move forward with the PRs. So from what I've seen right now, there was especially with TDX, it's at least some kind of a POC level, like a discovery level PRs. And am I correct?
Yeah, I think Matthias is there. He can speak more about it. But yes, I think
Yeah.
that's the first attempt. Yes.
So, like one important part is that we need a proposal. We need a proposal. We need to approve it, schedule it for a release, and then we could move forward with the PRs.
Is that also the case for the SMP one? Because that has been reviewed by Alicia and some others, if I'm not mistaken. But is that also required for that?
Yeah, I'm pretty sure. I mean, I don't know like what's the status of it. Sorry, I didn't specifically track that, but it's not in the it's not scheduled for this release. So
yes,
there was
yes, for sure. Yeah. Okay, so basically we need to come up with a proposal. The authors needs to come up with the proposal.
Yeah, and if you need help, just let me know. Alan.
Hi, yeah. So I'm the one who's taking over the SEV SMP work. I can't remember his name, but he's from Google. I'm taking it over. I have a draft PR for it, so I'm going to also have to create a proposal for this.
Yes. So there's a project in KubeVirt that basically accepts these proposals. Then they are being reviewed and scheduled for a next release.
Okay.
So it's a good time to file this proposal now if you wanted to move forward with this for the next release.
Okay. Yeah, I'll get started on that.
Yeah. Thank you. All right. So let's move forward with the agenda. Roman, you again.
Sorry. Yeah. AOMMUFD seems to be also something we have to crack. At least there are a few gaps. The GPU device plugins, I just recently did a small change to the KubeVirt GPU device plugin from NVIDIA to support IOMMUFD, but I think like long term it looks like it's more a DRA thing that we have to look into specifically, because when we attach multiple GPUs, you have to also think about NV-switch attachment as well. And the other big thing, which we don't have yet, seems to be libvirt support. I've seen like for 2 or 3, I found some threads which are 2 years old or 3 years old talking about IOMMUFD for libvirt. I could assume that someone is probably working on that, but I have no insights and was wondering if someone knows what's going on libvirt regarding to IOMMUFD.
I run the libvirt team in Red Hat, and I'm not aware. So I think I need some more entry points from you, Roman, justifying. I mean, how this is important. Why is this needed? And I can certainly, I mean, start moving this internally, right? I mean, if we line up our requirements on how this is important, is that
so the point is, without IOMMUFD support, there is no confidential GPU. That's just how it is. So that's the basic.
Okay. I wasn't aware, to be brutally honest. So yeah.
It's not that tough. Like we did some QEMU extra args workaround, and so it works right off the box right away.
Not
but
even the
yeah.
NVIDIA H100 proprietary driver type of thing?
No, they all require IOMMUFD.
Okay.
I actually tried just because I was curious. I also attach them with VFIO. And it's pretty fun. Like just the mapping of the GPUs can take 1-2 minutes on boot time into the guest, but they are not working then. Like it doesn't have the features which are required.
No.
So it's an NVIDIA requirement. And you can also look at the CC deployment guide linked in the docs. You can also see their QEMU arcs they're using. And they do not explicitly mention that it's IOM UFD, but it's de facto needed.
Mm-hmm.
So I created a comment task here for myself, but I mean, if there is any additional information, just keep adding to the document. I'll follow that up offline.
Yeah.
Roman, you again.
Yeah. Which confidential as attestation support is also interesting. I saw someone Matthias also added a subcomponent there already. Like that's another thing where you mentioned it already, where the requirements between the technologies drastically differ. Like for GPU attestation, there is no host infrastructure required. For SMP, I also don't think there's host infrastructure required. But Intel requires the QGS local daemon. So that's probably something else where it may make sense to look into a good entry point for these technologies in our project. I'm not sure if they need to be included. Yeah.
And even on the SNP case, if we think about SVSM coming in the future, secure virtual server machine coming in the future, we will probably need an attestation proxy at the host, right? So so this is why we need to do that spreadsheet and start mapping out what are the minimal viable, I don't know, common denominator there. Because if we already need something for support for a sidecar process like that for TDX, we might already add a general support for that, right? But yeah, Matthias, I think you have a suggestion on how to handle that, right? You wanted to talk about it?
Sure. Yeah, I think I brought it in the document. I think you mean how to handle the restore service. In our case, we put it one in the beer launcher. And the idea is to have the second service, the MPI registries in the beer handler. And that is just a proof of concept, and we are still discussing this. We also have one PR, which does only the enablement of the TDX. I see some of you maybe already saw it. And we plan a second PR for that station. I just learned now that you will need to write a proposal or something like this before. So I think we're going to do that. I'm still not super familiar with KubeVirt and all the architecture. So, which means that I agree that, for example, the fact that we put the quad service in the beer launcher, maybe it's not the right thing to do. So now we're discussing another way to do it. Yeah, I don't know if you have any precise question about this.
I am curious about one thing. I mean, the QGS, and maybe Miko here can also help us. Is it a privileged process? I mean, does it needs to run with privilege? I mean, with elevated privileges, or can just run as a regular? I mean, unprivileged KubeVirt pod.
I was actually about to comment on that. So it's not a privileged process. The only thing that it needs is the access to the SGX device node. So there's a bit of a chain of dependencies to have like an SGX device plugin or some device plugin that then grants the pod the SGX device node access. But other than that, there's no privileges. And we actually do have a daemon based setup already available for this TDX QGS. So it can run fully cloud native already today.
Okay. So the idea is to have one instance of it serving the entire node, or one instance per pod?
One instance per node, so that's enough. So it can serve all of the KubeVirt pods or VMs.
And I don't know enough about KubeVirt architecture, but I mean, is that, I mean, easy to do? Because I thought that it would be very difficult for us to have like one daemon where every I mean different pod in the compute node would require on, right?
So
in terms of permissions, in terms of, let's say, multiplexing that. So
yeah, so there are a few things to consider. I think, like the first thing I said, it's also, I think, better to have it on the host level because it so there is QGIS always needs to fetch the host certificates so that it can create a signed quote from Intel, and it has its own local cache, which I think by default is 7 days or something. But during that time, it doesn't have to refetch, and I think you need an API key as well, right?
QGIS doesn't need that, so it's mostly the caching. So, or at the time you provision the certificates, then you need the API key. But once you have everything cached somewhere, QGIS itself that doesn't need any API keys.
Yeah, but like if we have it now in Virt Launcher and we start 300 VMs, then we would hit your server 300 times, right? So that's probably not something you want. So
QGIS can do it. Well, I don't know. We haven't really done that type
what
of
I mean is,
like
you have the PCCS, for instance, in addition to QGIS. That's the cluster-wide service, which acts as a proxy between your trusted API and QGIS. And that one needs the API key, for instance, because of DOS concerns and so on, right? So if we would now put QGIS in each launcher, then it would basically do N calls for NVMs, which is probably not in your interest.
Yeah, but I don't think you want to do anything like that. So it's like think of it like PCCS being like one per your maybe data center, and then you have like these QGIS services, one per each TDX capable node. And even QGIS, like you said, you can do like node local caching. So your node local caching can then serve all those per node KubeVirt in instances just fine, and you won't be doing any remote access.
Yeah, I just wanted to strengthen the argument to not have it in launcher, but have it really once per node, right?
Oh, okay.
So, yeah. So basically on your side. But there was one other thing I wanted to say regarding to that. Yeah, just one final thing, and this is, I'm not sure if we should have QGIS included in KubeVirt. We may also wonder if we want to keep it as a separate thing, like that you can basically have an attestation stack outside of KubeVirt potentially, where just KubeVirt can pick it up and talk to. That's another alternative. So I just wonder also regarding to node readiness. It has some questions for scheduling, like do we consider a node then ready for scheduling if it has attestation service, or is it also ready for scheduling if it just is sufficient, is okay to start a TDX guest, but attestation may not work at the time.
Can't it be like a scheduling constraint with I don't know, something that labels the node with it?
Yeah, I guess it's just mostly on the API, a decision to say like, we possibly we would have to give users the decision to say like, and I also need attestation, right? So only go for attestations or something like this. Also, QGIS is a reference implementation, so if it helps us to integrate this part in Go code, for instance, it's probably also doable. There are many possibilities, right? A lot to think through.
So right now, Matthias, you have that inside the launcher, right?
Right. Yeah. What I wanted to ask is that, well, if maybe it is better to have one per node, I should start to think in doing that way instead of just submit the PR in the current state. Yeah.
Yeah, I think that would be more the intended pattern on how to use it, and also from a caching perspective and so on.
Okay. Thank you.
Are you, just out of interest, are you using the VSOC connection?
No. I mean, current QGS is using Unix socket between QEMU and QGS. Yeah.
Oh, interesting. Thanks.
Yeah.
Both options are available, meaning that you can make QGS to listen either local VSOC or UGS, Unix domain socket, basically. So
Yeah, in our POC, we were using the VSOC option where it's very easy then to talk from everywhere to it, right?
yeah.
There is some ongoing discussion on the QEMU mailing list, though. I mean, so I believe Daniel Berenger provided some feedback about the communication, I mean, between QEMU and QGS that I believe Intel is working hard to address and find ways in which those things are not, prone to man in the middle attacks or impersonation or replay attacks, right? So I guess there's some dynamic expected in that as well. I mean, in the next few weeks, hopefully.
If I remember the comments correctly, it was less about VSOC versus Unix socket. It was more like packet validation. Like I think QEMU is right now passing through raw packets. And so it's more like if code lands in the KVM part or lands in QEMU for validation. I think that's the main.
Yeah, correct. But on that note, Daniel also did make a comment about this UDS versus VSOC, saying that Unix domain sockets are better suited for host in-process communication. So that's what I've been thinking that I might look into taking in my configs for the future.
Yeah, makes sense.
All right. Let's see what's next. Yeah, so the next item listed is a thread from ARM about ARM CCA. Can anyone speak to this, or I'm not sure who
Yes.
added this. Oh yeah.
Hi.
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 Yeah, good to see.
Yeah, I come here to learn about CCA because I'm not expert on this area. I shared some current status on CCA on ARM64. So the confidential computing on ARM64 is supported in an experimental state. Yeah, we do have E2E demo, but all in experimental. The software well is in experimental. The kernel is in experimental. So there are two main patch for CCA in kernel. The first one is support for running as a guest in ARM CCA. This one has merged in Linux 6.13. Another one is enabling DMA in CCA. I think which is used for the device is still under review. And currently we do not have hardware. And maybe in next year we will have 64 CPU which support Realm, which is ARM version TDX. So if you guys want more details about this, I put a link here, and also I attached another file in the mail list. You can get more information about the current status of the CCA on ARM. Yeah.
Okay, perfect. Howard, is there anything that we need to consider now while we're developing the other support for the other architectures?
No, I think. Yeah.
Okay. Right.
Thank you.
Thank you. Yeah, so I guess this is the end of our agenda. So there are a few action items that we'll need to prepare for the next meeting. How often do we want this group to reconvene, and is the format good enough for us, or any suggestions?
What's the current schedule? Every 2 weeks, or?
I don't know. Andrew, do you know?
This is the first meeting, so we can determine that now. And also whether this, so this is a temporary meeting slot that we generally have, and I'm sorry that it's still called DRA support in KubeVirt. It's the last big conversation we had using this slot. Yeah, we can decide every week, every 2 weeks, every month. It's kind of up to people and whether or not this works or whether it clashes with anything. I mean, 30 people, it's going to be tough to find a spot that's good for everyone.
Does every 2 weeks works for everybody?
That sounds good.
Yeah, at least initially, if we have, I mean, enough things going on. If we have 2 in a row that are not much going on, we can go for monthly. Right?
Sounds good.
Yeah, perfect.
I will add, I mean, something for everyone to think about for the next meeting, perhaps. We need to think about attestation in terms of, I mean, what role does KubeVirt wants to play in attestation? Is it something that we are completely delegating to the user, to the guest owner? Is it something that KubeVirt want to have any say in, I mean, coordinating? I think that, I mean, it's too big of a question for us to debate now, but maybe we should, I mean, keep that in the back of our minds and think a little bit about, I mean, what our opinions are about an attestation server and how it fits on the ecosystem of KubeVirt. I mean, are we responsible for it? Are we managing secrets? Are we managing any policies or anything, right? Or not? Are we completely washing our hands on it, right? So,
Plus one on
okay.
that. I'm not sure if we want to completely wash our hands on that, but keeping it separate to a degree may be helpful, since we mostly deal with reference implementations there.
Mhm.
Like for instance, in our case, we have our own TDX stack. We actually have now HTC implementation of it and one for KubeVirt. And they're all independent of KubeVirt as such.
Yeah.
And we integrate them to different caches and all this kind of stuff. So I'm not sure if we can address all the needs if we build it in. So it should be being pluggable, may be useful in general.
Yeah, I wonder if it could be a separate project in the KubeVirt org, and then it would be easier to consume it whenever we want to test even.
Yeah.
Yeah, I think, yeah, providing reference implementations again here may be nice, but maybe not saying this is what you have to use. That's would be probably cool.
Yeah, again, there's something for you to keep in mind, because I think we will eventually need to talk about our role, KubeVirt role in attestation, and how much we care about it, how much we don't, right? Yeah.
A good point.
I think some of that would be useful to demonstrate to users, like building on top of attestation is like how to bring encrypted protected storage to your VMs, and how to unlock your protected storage partitions inside the confidential VM and things like that. For all of those things, we need attestation, and we need key provisioning in some ways.
Yeah, I didn't want to. I mean, I guess spend too much time on this, but I mean, we have different industry references for hypervisors and cluster systems managing hypervisors that are doing this differently, right? It would be good for us to identify if the user experience for managing confidential resources is part of what KubeVirt wants to play ball with, or not, right? What philosophically, what it means for mitigated confidential guests inside a cluster, a KubeVirt cluster, right? Are we managing any of that, or are we delegating this to the guest, to the respective guest owners, and not managing that at all, right? So anyway, I can't even put my finger on it, completely, but I think it's something for us to keep in mind on.
All right, sounds good. So this is the end of our agenda, I guess. We can wrap this call.
I have one more question, maybe a bit silly one at this point. So this document was shared, and you mentioned this doc a few times. At least I'm not able to access it. So how do I?
Oh, which one? Oh, the. So I think, Miko, what you need to do is to be part of the KubeVirt org.
I think it's enough to just join the mailing list. Just join
Yes.
KubeVirt Dev, and you should be able to
Correct.
access it.
Yeah.
Okay, yeah. I need to do that then. So good to know.
Hi, I have a question too. I'm curious about in which situation or scenario we need CCA, like private cloud or public cloud.
Both, I can say.
Yes, because I talked with many Chinese cloud provider like Alibaba, Tencent, and others. They always say security is important, but when their public cloud user, use their instance, they always turn off their security features in order to have better performance. Yes, so CCA. I know if we enable CCA, we will get a great performance degradation. So in which scenario or in which, I don't know, environment, we do need CCA?
Yeah, my personal opinion, Howard.
Yeah.
Confidential computing was born out of it's multiple scenarios. The thing that I guess multiple motivators for this, but the thing that I guess pushed it over the line was cloud computing, right? The need for vendors, cloud computing vendors, to actually offer private environments for their customers, right? And with that, not only diminish some concerns about, regulatory concerns, geographical concerns, right? Things like that, but also even, allow cloud infrastructure providers to, not really be associated with the workloads that they are selling their infrastructure for, right? So it's something that benefits both ends of the cloud computing scenario, right? So this is what I guess was the ultimate motivator for confidential. But if we think about it, even for in-premises, there is a lot of great scenarios in which this could be useful as well. So think about auditing, right? If you are managing a cluster for healthcare, right?
Yeah.
And you need to make sure that everyone, with access to that cluster is audited, or it's going through training or through auditing for having access to healthcare sensitive data. You could actually make an argument that you have technical limitations in place, that you don't need to put the KubeVirt administrators to that same auditing or through that same training or that same annual revalidation, right, of I mean, healthcare industry, I mean, certifications, right? I mean, you could put only the guest owners, and each of them could have even their different, I mean, particular, I mean, auditing requirements, right, that are now not applicable any longer to the hardware provider, to the cluster administrators. So this, I guess, could save a lot of money, right? And as you mentioned, it will never come for free. I think we did a few testings here and there and see that, I mean, in a couple of cases, the performance is good enough, but it will never be no performance loss. Not to mention about the limitations we will have about sharing things, because if you are confidential, it means that you cannot share a lot of things any longer, right? But to me, I mean, there's enough regulatory auditing and privacy concerns going around any longer around, I mean, in the world today. And AI is yet another one, right, where even in premises this will be important. That I guess this is so obvious to me. I mean, and for confidential, for me, in a couple of years will be like, I mean, nobody will even think about running stuff non-confidential mode, right? I mean, it's going to be the default probably in a lot of scenarios, right?
Okay.
Yeah, plus one. And I wanted to add here, like, to make another media example. There's like, in general, there's always the deadlock. Cloud providers saying, no, you have to run your stuff on us because we will not run our IP on your data center. And the customer is saying, no, I will not run my stuff on you because I don't want to send our IP to you. Right? It is always. And this is kind of what confidential computing both directions can solve. It allows the service provider to run their stuff protected at customer side, and it allows the customers to run their stuff on cloud provider's side, also protected.
Yeah. Okay, thank you.
Yeah, I think it's the hand.
Yeah, so I'm Red Hat's representative to the Confidential Computing Consortium. If you want to know more of the use cases, we have a couple of white papers that are great conferences. OC3, there's Confidential Computing Summit coming up in 2 weeks. It talks about the use cases. So won't go into a lot of detail, but feel free to reach out to me if you want to talk about it, or anyone wants to talk about confidential computing. Thanks.
By the way, Miko, Yash, did you manage to access the document?
I haven't joined the group yet, but it'll be fine. I'll join after the call.
Let me check. Let me close the window. I'll check and get back to you offline.
Thanks. Yeah, if there's anything, just ping me or Andrew.
Oh, before we leave, there's one final interesting thing, and that are TPMs, which is also worth an extra discussion, since we have no secure TPMs at the moment because they're software related. Maybe something for next time.
Will you add the agenda for the next time?
Yeah, I'll edit for it.
All right. Was good seeing you, hearing you all.
All right. Thank you.
Thank you for
Good
joining.
start.
Yeah.
Thank you. Bye.
Thank you.
Thanks. See ya.
Thanks, Max.
Bye. Thanks.